be here again.
All right, we're going to pick up with on module 5 here, transmitter functions, and that's talking about your radio sending signals out. And we're going to talk about transmitter output power, and how that's adjusted. In most radios, you can adjust your output power. I'm going to slide that over here. In HF rigs and radios using AM, single sideband, and CW, you can control it's controlled by a power knob. So it's a radio frequency power knob. You can go from 0% power up to 100%, and that happens mainly on your HF rigs. When we talk about FM and handheld mobile radios, such as this one right here in my hand, it has a selectable fixed power level. You can set it to transmit on low power, medium power, or high power. So usually you see that in handhelds where you can adjust them, like this handheld. I can't get the camera to pick it up. Let's see. Put something behind it. There we go. Uh, so you can adjust the power that it transmits. It's low, medium, and high. So it's kind of a fixed power level. The microphone gain controls the level of speech audio in single sideband transmitters. You can actually adjust that for how well your microphone picks up. Uh, in Again, in the little handheld radios, that's a fixed microphone gain. The way you adjust the gain is you move in close to the microphone or you move away. And we'll talk about this is sounding pretty good. We'll talk about what this is here in a minute. Switching between receive and transmit on voice. Uh, Manual push to talk. It's going to be the PT2 button. Again, if you look on the side of this radio, there is a little button that you press to talk. I'm not going to press, it's off, so, but you would press the button to talk, and it's referred to as a PTT button. There is also a way you can set it so it's a voice operated transmitter. So when it hears your voice, it automatically goes into transmit mode. Personally, I don't use that because uh, usually where I'm operating from, there is some noise in the background, and you don't want your radio transmitting or picking up noise from the background and transmitting that out. But some people use that during contesting. They'll put on a set of headphones and have a microphone, and they'll use that when they're contesting. On CW mode or Morse code, you use a key, an electronic keyer. It's faster than manual. And here again, I think I showed this last week. This is one example. It's just a single button like you would see in the old westerns, the telegraph. That's the kind of key they used. And then this is a paddle where one paddle represents a dot, and the other paddle represents a dash. And I'm not coordinated enough to do Morse code. Uh, then you can use a dummy load, like if you're testing your station and you're wanting to adjust the transmitter. A dummy load can be used to avoid interfering with other stations. What you literally do is you disconnect your antenna from your radio and you put this dummy load on, and then you can adjust your power and your settings. And basically, a dummy load is a heavy resistor that can absorb and dissipate your output power on your radio. And I'll show you a dummy load here in a minute. Spurious signals, excessive modulation results in distortion of transmitted speech. Spurious outputs on adjacent frequencies is called splatter. And especially when you get your general license and you get into saying hunting parks on the air, you'll hear there'll be stations out there and there'll be several frequencies up from where you are, but you can still hear them because their signal is splattering across the spectrum there. Overmodulated FM signal has excessive deviation. It's called over deviating, and it's used by speaking too loudly into the microphone. So if I'm down here like this, I'm over deviating right now. So that's basically um, what that means. You're too close, and when you get into radio, you're going to have a little mic fright, and you might be trying to communicate with your little handheld, and you're holding it too close to your mouth, or you're talking too loudly in it, and somebody may say, "Hey, you're over deviating," and the best way to adjust that is move it away from your face and not bring it up so close. And you'll have that mic fright, I guarantee you. I did. It took me probably months before I really got over it, and sometimes for no reason I'll have a little mic fright when I'm doing a net, and we'll talk about that next week or in a couple of weeks. Overmodulation of an AM or single sideband signal is called by speaking too loudly or setting the microphone gain or speech compression too high. So, as we said on HF rigs, you can adjust that gain, and if you adjust it too high, it's going to pick it up. Or you're speaking too loudly, that's a cause for overmodulation. And believe me, the operators that hear you will let you know that. All right, so that's the transmitter side of the radio. Now let's talk about the receiver side, or receiving signals in. AF gain or volume control sets the speaker or headphone listening level. So there's a little knob on these little radios where you can adjust the speaker sound. All radios will have that. RF gain adjusts the sensitivity of the receiver to incoming signals. So you can adjust the radio frequency gain to hear incoming signals. Automatic gain control adjusts sensitivity to keep the output volume constant, but for both weak and strong signals. And then squelch mutes the receiver's audio output when no signal is present. It eliminates the continuous noise. So if you've got your squelch turned up, you're not going to hear the what I call the white noise from there being no radio signal. If you turn that squelch down or you open your squelch up, you'll hear that white noise, and you can also pick up weak signals that way. Because sometimes when the signals are real weak, if you've got your squelch turned up, you won't hear them on the radio. Many transceivers have a monitor switch that temporarily opens the squelch to hear weak signals. So I think, I'm not sure on this one, but I think I have a button on here that I can press on my little HT, and it will open up the squelch so I can hear a weak station off in the distance. Now, there's two terms that you'll see. One is selectivity, and think of that as being selective, and the other one is sensitivity, being sensitive. Receivers are compared on the basis of two primary characteristics: how sensitive they are and how selective they are, or selectivity. Sensitivity determines the receiver's ability to detect a signal. So if if they've got good sensitivity, they can detect signals well. It's specified as a minimal detectable signal level. A preamplifier is used to boost sensitivity. So you have a preamp that's going to boost a signal so that you can hear it. Selectivity, on the other hand, is the ability of a receiver to discriminate between signals. So you may have two strong signals coming into your receiver or into your radio, and if it's got good selectivity, you can tune one of those signals and the other one won't interfere. High selectivity means that the receiver can operate properly even in the presence of strong signals on nearby frequencies. So when I'm on my HF rig, sometimes I will get a strong signal right up against the frequency I'm on, but because of my radio, it can kind of keep that frequency from interfering with the frequency that I'm on. Filtering and tuning. A receiver rejects unwanted signals through the use of a filter. So think of a filter just like a water filter. It takes out the impurities that you don't want. Same thing with a radio filter. It's going to take out the signals that you don't want. Signals then pass through filters narrow enough or small bandwidth. Think of it as a small bandwidth to reject all but the desired signal. So if you're on, you remember, like, let's say we're on, I'll just use 17 meters here. I don't know if you can see that or not. But anyway, if you're on 17 meters and you're on a certain frequency, you can use filters to narrow out everything else, any of the other signals on 17 meters, and focus on the one or the desired signal that you want. Wide filters, they're around 2.4 kilohertz, are used for single sideband reception. And we'll talk about that in a little bit. Narrow filters, around 500 hertz, are used for CW and data mode. Multiple filters allow you to reduce noise or interference by selecting a filter with just enough bandwidth to pass the desired signal. All right, RIT, receiver incremental tuning, also called a clarifier, is a fine-tuning control used for single sideband or CW. So you can fine-tune by tenths of a hertz to pull in a signal. It allows you to tune in a station that's slightly off frequency or to adjust the pitch of an operator's voice that seems too high or too low. All right, let's talk about VHF and UHF radio frequency power amplifiers. A radio frequency power amplifier can be used to increase the output power by a factor of 5 or more. So we're going to send a radio signal out, but we want to increase that signal's power. And the way we do that is through an amplifier. Just like back in the day, if you're as old as I am, you had an amplifier, or you. Well, I didn't play music, but guitars, electric guitars, have a power amplifier to amplify the music. Well, this is kind of the same thing. You're amplifying your radio signal, and you're doing that by a factor of 5 or more. Many VHF and UHF power amplifiers can be used on all modes, including single sideband and CW, and you switch between the modes. When you're doing this, if you do an amplifier on your radio rig as you get into this hobby, be sure that you make sure that your antenna is capable of handling high power. You can literally burn up an antenna or burn up components of the antenna if you try to run too much power through it. And another thing you want to be sure that you learn about as you use amplifiers is about radio frequency exposure. You don't want to have too much radio frequency exposure to yourself, even though it's not radiation like the kind that causes cancer. You still want to be aware of the exposure. Now, transverters. By using mixers, it's possible to convert an entire transceiver to operate on a different band. Mixers are part of equipment called a transverter, and you notice that's in red, so there's going to be a question. A receiving converter mixer shifts input signals to the desired band where they are received as regular signals by the transceiver. Transverters allow one main transceiver to be used on one or more new bands. All right, we're ready for some practice questions. All right, which of the following has been used to enter a transceiver's operating frequency? Now, think about what you would use on a radio to change the frequency or to enter a frequency. Would it be the keypad or the VFO knob? the CTCSS or the DTMF encoder, automatic frequency control, or D, all of these choices are correct. I'm going to give you a hint if I can. You can see right there on my radio these. So what is that called? It's
The
called a keypad. So
keypad and VFO.
yep, the keypad on radios. Now, not all radios will have a keypad, but they will have a VFO knob where you can literally tune in the frequency. So the answer is going to be A. Now, again, let me remind you that when you take the test, this could be one of your questions, but don't remember the answer as A. Remember the keypad or VFO knob as the answer because when you receive the questions, the answers are always shuffled into a different order. So I want to just caution you about that. What is a way to enable quick access to a favorite frequency or channel on your radio? Enable the frequency offset, store it in a memory channel, enable Vox, use the scan mode to select the desired frequency. So if you've got a bunch of favorite frequencies, how do you think you would store them in the radio?
I want to respond, but I don't want to talk over everybody.
Jeannie, you're muted. I see you're talking, but you're muted. If you kind of tap on I don't know if you're on the phone, but if you tap on yourself, you should see audio and it should let you uncheck.
Okay.
There you
My
go.
phone kind of temperamental, doesn't always let me do it. I would think it would be store it in the memory channel.
Store it in a memory channel. That's correct. So that should be kind of easy. You quick access to a favorite frequency. You store it in a memory channel. We do that on our phones. We store a phone number in our contacts. We don't call it a memory channel, but basically that's what we're doing on a phone. All right, the next one. What is an electronic keyer? It's a device for switching antennas from transmit to receive, a device for voice activated switching from receive to transmit, a device that assists in manual sending of Morse code, or D, an interlock to prevent unauthorized use of the radio. Remember, there was one method that we used, and I showed you two different keyers, and it's for Morse code, C. And again, here's a keyer that you could see back in the Western days, looks similar to that, the old Western movies. And then here's what we call a paddle keyer. One paddle is the dot, and the other paddle is the dash, and I don't know which side's which. What is the function of a transceiver's push to talk input? Give you a hint there. PTT, push to talk. Input for a key used to send CW? Nope. Switches transceiver from receive to transmit when grounded. So we're going from receive to transmit, push to talk. That means you're transmitting. Provides a transmit tuning tone when grounded. That doesn't make any sense. An input for a preamplifier tuning tone. And the answer is going to be B. It switches your radio from receive mode to transmit when you push that button. So it's B. What is the primary purpose of a dummy load? And this is, I told you I'd show you a picture one. I included it on the answer. It's to prevent transmitting signals over the air when you're testing your radio, to prevent overmodulation of the transmitter. Nope. To improve the efficiency of an antenna. No. To improve the signal to noise ratio of the receiver. No. Think of a dummy load. You're connecting that to your radio so that you can make adjustments on your radio and transmitting adjustments so that you're not sending anything out over the air. The dummy load actually absorbs the transmission or the power, so it doesn't actually go out. And it's going to be A, or in this case, to prevent transmitting signals over the air when making tests. And Somewhere I've got a picture, I know. What does a dummy, oh, it's on this one. What does a dummy load consist of? Is it a high gain amplifier and a transmitting switch? Nope. A non-inductive resistor mounted on a heat sink. And we'll tell you that's the answer. You've got a resistor and it absorbs the signal. And when it absorbs that signal, it's going to heat up. And what the heat sink does, it dissipates that heat out.
Hmm.
And low voltage power supply or and a DC relay, nope. A 50 ohm reactance used to terminate a transmission line, nope. The answer is going to be B. And here's the picture. Inside that is a resistor, and then these rings are just heat sinks. So, so if you're transmitting a signal, you'd have your coax attached to this. And if you're transmitting and testing your radio, that resistor is going to heat up, and these metal discs would dissipate that heat out. It's kind of air cooled, like you would see on an cooled motor. And that might get warm, but it keeps you from sending signals out and interfering with other radios.
Pat, that's not used on a handheld, right?
Well, you could, uh, but most of the time, simply disconnecting your antenna on a handheld, you're not going to be making on a handheld. You're not going to be making a lot of adjustments like you would be, say, with an HF rig.
Uh-huh.
Uh, so
What does HF stand for?
high frequency,
Okay.
like your 20 meter, 40 meter, 80 meter bands, anything above. A technician license will basically operate in the 2 meter band and the 10 meter band. And so anything above 10 meters would be considered HF.
Okay. Thank you.
So you really wouldn't use that. You could if you were doing some testing. I've seen some YouTube videos where they use that on a handheld radio, and it's usually to demonstrate some kind of feature of that handheld radio. It's not really used to do adjustments to the radio and things like that.
Yeah. Thank you.
All right. What would cause your FM transmission audio to be distorted on voice peaks? Your repeater offset is inverted. You need to talk louder. You're talking too loudly. Your transmitter power is too high. Which one do you think it would be?
You're talking too loudly.
I'm talking too loudly. That's correct. So the answer is C. What is the effect of excessive microphone gain on single sideband transmissions? I've already demonstrated that several times. Frequency instability, distorted transmitted audio, increased SWR, or all these choices are correct.
B.
B is in Bravo.
Yes.
Yes, this distorted transmission audio. If you want to get up on the mic, you can transmit. I kind of like doing that. You can distort your audio.
And what's SWR stand for? I forget what all these little initials are.
Uh,
Do you remember? I don't know.
I don't remember right offhand, but
St-
basically what that means is your signal is going out to your antenna. Yeah, you may not between your receiver, your radio, and your antenna. It may not be balanced. So instead of the signal all transmitting out the antenna, part of it's reflected back. Standing wave ratio
Oh,
is
okay.
what that means.
Okay. Thank you.
Had to think on that one. What can you do if you're told your FM handheld or mobile transceiver is over deviating? Talk louder into the microphone, let the transceiver cool off, change to a higher power, or talk further away from the microphone.
E.
It's going to be D, talk further away from the microphone.
Yes.
Okay. What is the purpose of the squelch function? Now, you remember we talked about this. Reduce the CW's transmitted key clicks? Nope. Mute the receiver audio when a signal is not present. Eliminate parasitic oscillations in an RF amplifier? Nope. Reduce interference from impulse noises. The answer is no on that one. It's to mute the receiver audio when a signal's not present. So if nobody's transmitting, you would hear that white noise. I would call it white noise. But when you turn the squelch up, you cut that out. And then when somebody does transmit, it's usually above that squelch level and it will open up on your radio and you can hear them. So the answer is B on that one. How is squelch adjusted? Now think about this one. How is squelch adjusted so a weak FM signal can be heard? So when we turn the squelch up, we're cutting out noise, but this is a weak signal. So what are we going to do? Set the squelch threshold so that the receiver output audio is on all the time. Turn up the audio level until it overcomes the squelch threshold. Turn on the anti-squelch function. We didn't even talk about that. That's a distractor. Enable squelch enhancement. That's also a distractor. So you got a choice between A and B. So what are you thinking? It's a weak signal. If we had the squelch turned up, we
I
wouldn't
think
hear any of that. So it's actually, I'm going to tell you, it's going to be A. You set the squelch threshold so that the output audio is always on all the time. So if you got a real weak signal, you want to hear the background noise and you want to hear what's coming through. And if you've got a real weak signal, if that squelch is turned up, you're not going to hear it. So you want that background noise, that snowy sound. You want to be able to hear everything that could be on that band. Does that make sense to everybody? So the answer is A. You want that audio on all the time. Which term describes the ability of a receiver to detect the presence of a signal? Describes the ability of a receiver to detect the presence of a signal or how sensitive. Linearity, sensitivity, selectivity, or total harmonic distortion. Distortion. Well, we haven't talked about D. We've not talked about A. We've talked about sensitivity and selectivity. So the ability of a receiver to detect or how sensitive that receiver is to detect, it's going to be B,
Sensitivity.
sensitivity. What term describes the ability of a receiver to discriminate between multiple signals or to select between multiple signals? So think of it that way. The discrimination ratio, the sensitivity, the selectivity, or the harmonic distortion.
selectivity.
The selectivity. That's correct. Where is an RF preamplifier installed? So you're amplifying a signal that's coming in over your antenna. So where is this going to be installed? Is it going to be between the antenna and the receiver, at the output of the transmitter power amplifier, between the transmitter and the antenna tuner, at the output of the receiver audio amplifier? So you've got a signal coming in. It's going to be between the antenna and the receiver. So it's going to be A. Which of the following controls can be used if the voice pitch of a single sideband signal returning your CQ, and that means you're calling CQ, which means you're wanting a station to respond, and so they're responding to you, and their call seems too low, too high, or too low. So what are you going? Which of the following controls would you use to adjust the voice pitch of the signal coming to you? Would it be the AGC or limiter, the bandwidth selection, the tone squelch, or the RIT or clarifier? So we're talking about clarifying the voice of that signal coming to you. So the way I remember it, it's D, the clarifier. So the answer is D on that one. So if you got a voice signal coming into you and it doesn't sound very well, you can use the RIT or clarifier control.
Is that kind of like the volume on a
Yes,
handheld?
it's like the volume, or it's like not microscopic, but fine tune on the frequency of
Hmm.
the signal that you're getting in. You can fine tune it, and that would help clarify so that you can understand what they're saying.
Okay, thank you.
Okay.
Hmm.
What is the advantage of multiple receive bandwidth choices on a multi-mode transceiver? Permits monitoring several modes at once by selecting a separate filter for each mode. Permits noise or interference reduction by selecting a bandwidth matching the mode. Increase the number of frequencies that can be stored in memory. Well, that we can scratch that one. Increase the amount of offset between receive and transmit frequencies. We can kind of scratch that one off. And I think it's going to be B. It permits noise or interference reduction by selecting a bandwidth matching the mode. So you can kind of, again, it's kind of like fine tuning in on that signal. Which of the following receiver filter bandwidths provides the best signal to noise ratio for single sideband reception? 500 hertz, 1000 hertz, 2400 hertz, or 500 hertz. Now, we talked about that, but we weren't talking about hertz. We were talking about kilohertz. So if you go back three there, 2.4 is what we mentioned. So the answer is C, and that's because the usable voice frequency falls between 300 and 3000 hertz. And when in the slide that we talked about it earlier, we were talking about 2.4 kilohertz. What is the result of tuning an FM receiver above or below a signal's frequency? Change in audio pitch, sideband inversion, generation of a heterodyne tone, a distortion of the signal's audio. So you're tuning an FM signal above or below a signal's frequency. So what do you think it's going to be?
Distortion. No. Yeah. Distortion of the signal's audio.
You win a prize. The answer is D. That's correct. So the signal's audio will be off slightly if it's not on frequency. What is the function of a single sideband CW-FM switch on a VHF power amplifier? So we're talking about a switch on an amplifier. We're talking about these different modes. Change the mode of the transmitted signal. Set the amplifier for proper operation in the selected mode. Change the frequency range of the amplifier to operate in the proper segment of the band, or reduce the received signal noise. So we're going if we're doing single sideband, we want that switch to be set to single sideband. So we have the proper operation in the selected mode. I was going to say um, it's only one with amplifier, and then I just realized that this one has the word amplifier in it. But so you're setting the amplifier for the proper operation in the selected mode. So if I'm in single sideband, I'm going to switch it to that mode. If I'm in CW, I'll switch it to that mode. Or if I'm in FM, I'll switch it. So the answer is B, and I just hit the wrong button there. So the answer is B. You're going to set the amplifier for the proper operation in the selected mode. What device increases the transmitted output power from a transceiver? So we're going to increase the radio frequency, or the power of the radio signal coming out of our transmitter. So what do we use to increase that power? Is it a voltage divider, an RF power amplifier, an impedance network, or D? All these choices are correct. Well, I can tell you this one's not it. We're amplifying the signal. We're going to increase the power. So it has to be
B.
B,
B.
has to be RF power amplifier. What device converts the RF input and output of a transceiver to another band? We talked about that, and it was that weird word. It's not a high pass filter. It's not a low pass filter. It's the transverter. So it converts a radio so that it can receive another band, or is it a phase converter? So the only one there that would be correct is C, the transverter. Now, let's get into digital communications. And tonight, when I finish, I'm going to stop with Module 5. So we may go to 8 o'clock, or we may get done before 8 o'clock. But I think after tonight, we're over halfway done, folks. We're getting close to taking that test. I think the other modules, module 6, 7, 8, and 9, will be starting to get easier, I hope, or it's not as technical. So when we get done with Module 5 tonight, we'll stop and maybe we'll go use Ham Study or the ARRL website and do some practice testing. All right, why would you want to use a digital mode? And basically, a digital mode, as I've said before, is when you take a computer and you run some software on that computer and you connect it up to the radio and you send signals out. And somebody on the other side of the world or across the United States has a computer and a radio hooked up, and they're going to receive that digital signal, and their computer will decode it, or you will the two stations will exchange information. So special codes and characters are embedded in a stream of data that allow the receiving modem to detect or correct errors. So my computer may, through my radio, sends out a signal. Jeannie's radio may receive that signal, and there may be some errors in it. So her computer and radio will send back a message to my radio and say, hey, send again. And all this is done very quickly. You can't detect it with the human ear. It's done through the computer and the radio. And amateurs have developed or adapted techniques for changing digital data by transforming ones and zeros. So when we even talk about computers, that's how they operate. They operate on ones and zeros of data. They change it into tones that are in the same frequency range as the human voice. So amateur digital modes, different combinations of protocols or codes and modulations such as single sideband or FM are used to create digital modes. And we're going to talk about what those are. Popular HF digital modes is RTTY or radio teletype. It's probably one of the oldest ones. PSK 31, and that's keyboard to keyboard. So that's kind of like text messaging today with a phone, but you're using a computer and a radio to send messages back and forth, keyboard to keyboard, and that the stations can be thousands of miles apart. FT8 and Whisper. FT8 is very popular now. I've done FT8 and I've exchanged information with stations in Russia, nearly all around the world. And so FT8 is a very popular software that people use if you don't like to talk on the radio. And I found that some hams don't. This is one of their favorite hobbies to do in ham radio is to do FT8. And basically you're exchanging signal where you're located with the other station. And it's all logged in the computer. Pactor or Winmore, WinLink messages. That's kind of a email over ham radio. And popular VHF and UHF digital modes are packet radio, B2F protocol, again, WinLink, JT65 for moon bounce, and MSK 144 for scatter pass. We used to have a ham radio operator in this area. He did a lot of moon bounce, and He passed away before we could tap into that knowledge. IEEE or 802.11 Wi-Fi adapted to amateur use on microwave bands. And popular voice is AOR or FreeDB, and that's HF, and I'm not familiar with those. D-Star, System Fusion. System Fusion is, you've heard me talk about Yaesu radios. That is their proprietary communication that you can use between Yaesu radios, but they have to be equipped with C4 FM. So not all Yaesu radios can do System Fusion, only those that are equipped for it. And then you have DMR and P25. So those are different ways to communicate, kind of a combination between radio and the internet.
So, Pat, I have a quick question. I
Sure.
hear on Tuesday, is it Matt that does a fusion and something or other? I never
Yes.
understood what that was. Is that related to what we're talking about now?
Yes. Yes, it is. When uh, when Matt does the System Fusion net, he is using a Yaesu radio. I'm trying to get back to it. Yaesu radio that's equipped with C4 FM, and it allows people with that type of radio and brand of radio, they can communicate basically from around the world if they want to.
And you're not talking about a handheld Yaesu. You're talking about a regular high frequency rig, right?
No, I'm
No.
talking, it can be a handheld, it can be a mobile station, as long as it's a Yaesu radio that's equipped with the C4 FM capability, it can be part of that.
How do you know if it's equipped with that? Because I have a Yaesu handheld, but it's an older one though. It's really old.
You have to look at the specs on it. And if it says it's got C4 FM in it, then yeah, you could do that.
Okay. Thank you.
You're welcome. All right. Packet and packet networks. On VHF and UHF, the most common digital mode is packet radio. Data characters are transmitted in groups called packets. Frequency shift keying is used to transmit individual characters. And each packet consists of a header, data, and checksum. If an error is detected, the receiver automatically requests the packet be retransmitted until the data is received properly, and ARQ, which stands for automatic repeat request. So if you send out a signal to another radio and it doesn't get that header data and checksum, it will send back a response saying, hey, I didn't get that. Send it to me again, and that will continue back and forth until it's got the correct data. Digital modes that are designed for real-time person-to-person communication are called keyboard-to-keyboard modes. Most popular on the HF bands. Most are generated by computer software using a sound card and an interface to transmit audio input and output. And I will say, most newer radios will have a sound card built in, so you don't need that piece of extra hardware. So when you're buying an HF radio, you want to check the specs on it, make sure it's got that sound card built in so you don't have to make a extra purchase. Radio teletype, or TTY, is the oldest, and most popular is PSK31 or phase shift keying, and it's at 31 baud. And if you remember back in the dial-up days, you had to set the baud rate on your modem, and that's kind of what we're talking here about, is the rate of transmission. It works very well in noisy conditions. And then APRS is another one. I have a handheld radio that I've got set up when I'm traveling that will transmit an APRS packet of my GPS location. And if there's another station out there, they can pick it up and kind of see where I'm located. It uses packet radio to transmit the position information from a moving or portable station. Basically, a packet radio station combined with a global positioning system or receiver can transmit GPS positions. There's some ham radio operators that will launch a helium balloon up, and they'll have an APRS system on there, and they can track that balloon as it travels across the country or around the world. You can also transmit weather information and short text messages with APRS. A common public service application of APRS is to provide maps of station locations while they're providing real-time tactical communications. Here's a setup, and again, this is a little dated. You can see by the computer this is old, but you would have a cable that would connect to that, basically a sound card that would connect into the computer. The radio control for the data, it's either be on a COM port or USB. Well, most computers don't have COM ports anymore. It's all USB. And so this is kind of a setup. So just think of a computer. It doesn't have to be a big desktop computer. I have a little Raspberry Pi that's not quite as big as my cell phone that I can use to run FT8 on and send signals through my radio. The radio that I have has a built-in sound card. Setting up for digital modes, a very popular example of a sound card mode is FT8. So FT8 is basically run by the computer, and you just confirm a contact when it pops up on the screen. If you use a sound card, you may need a digital communications interface to supply the push-to-talk signal for the keying of the transmitter. Again, as I said, most of your newer radios will have that built in. Some of them don't, so you would have to buy a device that would connect the computer to the radio so that it would enable the push-to-talk feature. This is really an old diagram. They still talk about dial-up. I don't think anybody has dial-up anymore. I hope they don't. Bless their heart if they do. But you've got the computer. You have a radio here. It's a transceiver. It can send and receive. You got a data interface. And then you can have a gateway. So the radio receives something from another radio. It can feed it into the computer. Then the computer can feed it out to the internet. So an internet gateway is a station. An internet gateway station is a regular digital mode station and also runs software that relays data to and from the internet. The most common example of gateway stations are APRS gateways and WinLink. Again, I said WinLink's an email over radio, RMS station. So I may be out with my little handheld and I'm transmitting APRS data. Somebody has a setup similar to this. They're receiving that information, and with the software that's on that computer, it can be relayed out to a map, and that map can show my location on the where I am located in town or wherever I might be.
Do most hams use WinLink?
Pardon?
Do most use WinLink?
No, I don't. I haven't gotten, again, I'll go back to my quote, ham radio is a hobby of 1,000 hobbies, and WinLink or email over radio is one of those hobbies I haven't gotten to yet. I hope to at some point, but there are some people that use it all the time. It's used, a lot of hams will use it when they're doing emergency communication practice and so forth. So that's something that I hope maybe in the future we can get somebody to present at our club meeting on WinLink. The gateway shown in Figure 511 is a special kind of digital station that provides a connection to the internet via the amateur radio. Most gateways are set up to forward messages. And again, when you're using an amateur radio and you're taking in messages and you're sending them out to the internet, just because you're connecting to the internet doesn't mean that the rules and regulations about commercial and business related messages and the communications apply to the internet gateways. You still have to follow the amateur radio rules. You can't send a text message out and it be business related or commercial related, you've got to it's still got to be messages that follow the amateur radio rules. Now, WSJTX is a software suite, and it's got several different things within that suite. One of them is FT8. It's free. It's an open software program. It was developed by Dr. Joe Taylor, K1JT. He's a Nobel Prize winning astrophysicist and his team. It's designed for weak signal digital communication, and it's used in amateur radio. And it's free. Well, I got that in there twice. And it implements communication protocols of modes called FST4, FT8, FT4, JT65. Those are some of the most common ones. Whisper is another one, MSK 144, and one called Echo. It's designed for making reliable, confirmed contacts. A QSO is a contact under extreme weak signal conditions. Common digital modes in WSJTX software is the FT8. That's most widely used today. It's short automated exchanges. They last no more than 15 seconds. And as I said, I've used it and I've made contacts as far as Russia from here. FT4 is similar to FT8, only it's half of the cycle time. It's used most of the time when you're in contests, and some contests don't allow digital modes. The JT65 and JT9 are for extremely weak signals, and it's a older but still supported mode. And Whisper, a weak signal propagation reporter, it's used for testing and mapping propagation paths. So there's a website out there that you can go to, and it will show you how well your signal is getting out from where you are. Now, some practice questions. Which of the following is a digital communications mode? Packet radio, IEEE 802.11, FT8, and D, all of these choices are correct.
Packet radio?
Well, we know C is one, and we know A is one, so by reasoning here, it's going to be all three of them. So it is all choices. All these choices are correct. Which of the following best describes an amateur radio mesh network? An amateur radio based on data network using commercial Wi-Fi equipment with modified firmware. A wide bandwidth of digital voice modes employing DMR protocols. A satellite communication network using modified commercial satellite TV hardware. Or D, internet linking protocol used to network repeaters. Well, we know it's not that one. I'm going to come back up here, an amateur radio based on data networking using commercial Wi-Fi equipment with modified firmware. So it's a radio mesh network. So the answer is going to be A. And I was going to tell you about it's not amateur band, but there is, I can't think of it right now, but it's becoming very popular. It's a little bitty transmitter, and you can connect it to your phone, and you can have different people sending text messages over this little transmitter. They kind of have to be in close proximity, and when I say close proximity, usually a mile to a mile and a half, and whatever that's called, it just went that way. Maybe when it comes back, I'll let you know. Which of the following operating activities is supported by digital mode software in the WSJTX software suite? Earth, Moon, Earth, which means you're sending a signal from the Earth, you're bouncing it off the moon and back to the Earth. Weak signal propagation beacons, meteor scatter, or D, all these choices are correct. Well, we talked about Earth, Moon, Earth. We talked about weak signal propagation, and we didn't really talk about meteor scatter, but that's when you have meteors hitting the ionosphere and ionizing it and causing signals to bounce off. So it's going to be D. All these choices are correct. What is FT8? A wideband FM voice mode. Well, we know it's digital, so we can knock that one off. A digital mode capable of low signal to noise operation. That's a very strong contender. An 8-channel multiplex mode for FM repeaters. That's a distractor. A digital slow scan TV mode with forward error correction and automatic color compensation. So what do we think it is?
A digital mode. Oh, I'm sorry. Go ahead.
No, I was going to say B. That's all. Go
A
ahead.
digital mode capable of low signal to noise operation.
That is correct. That is correct. It's going to be B. Which of the following is included in packet radio transmissions? We talked about a header. We talked about, it's not called a footer, but we talked about 3 components here. A checksum that permits error detection, a header that contains a call sign for the station for which the information is being sent, an automatic repeat request in case of an error, or D, all these choices are correct. We actually talked about all these. Checksum that permits error detection. So if the receiving radio doesn't get that checksum, it can say, hey, it can do an automatic repeat request. So that's C. And usually there will be some information that contains the call sign of the station which is sending it. So it's going to be D. All these choices are correct. What is an ARQ transmission system? A special transmission format limited to video signals. A system used to encrypt command signals to an amateur radio satellite. Excuse me, an error correction method in which the receiving station detects errors and sends a request for retransmission, or D, a method of compressing data using autonomous reiterative Q codes prior to final encoding. That is a distractor. So ARQ, automatic request. So
C,
it's
which
going to
is
be
it's not C, but it's an error correction method in which receiving station detects errors and it sends a request back for retransmission when it
that.
doesn't meet the criteria.
That is correct. That is correct. So it's an error correction method in which if the receiving station doesn't receive the correct information, it'll go back and say, hey, send it again. And it will continue to do that till that signal gets through. What does the abbreviation PSK mean? We kind of went through that kind of fast. It's not pulse shift keying, phase shift keying, packet short keying, or phase slide keying. It's actually B. I think the way I remember this one is I know it's a phase, and I think about the shift key on a keyboard. So phase shift keying is the answer. What kind of data can be transmitted by APRS? GPS position data. Yes, we talked about that. Text messages and weather data. D, all these choices are correct. With APRS, you can get short text messages and you can get short information about data. So it's going to be D, all these choices are correct. Which of the following is an application of APRS? Providing real-time tactical data communications in conjunction with a map showing the location of stations, showing automatically the number of packets transmitted via Pactor during a specific time interval, providing voice over internet connection between repeaters, providing information on the number of stations signed into a repeater. This was directly from the slide, and it's to provide real-time tactical data communications in conjunction with a map showing the location of the stations. So think of it, APRS, one of the main uses is to show your location. So remember a map showing the location of stations when you have APRS. So it's going to be A, or this answer. I shouldn't say A, but for this question, that's the correct one. How are the transceiver audio input and output connected in a station configured to operate using FT8? To a computer running a terminal program and connected to a terminal node controller unit? I'm going to tell you no. To the audio input and output of a computer running the WSJTX software? To an FTA conversion unit, a keyboard, and a monitor computer? To a computer connected to the ft8converter.com website? Well, remember we were talking about a digital mode and it's between the computer and radio. So the only one that really makes sense to me is B, and I hope that's right. And it is to the audio input and output of the computer running that software. So the radio is going to be the way you connect your radio to the computer running the WSJTX software. You're going to have audio output and input. And usually that's through the built-in modem on the computer. What signals are used in a computer radio interface for digital mode operation? Well, think about it. What kind of signal is the radio going to send out and receive when it's connected to a computer? Is it going to be receive and transmit mode, status, and location? Is it going to be antenna and RF power? Is it going to be receive audio and transmit audio and transmitter keying? So if I'm just talking on the radio, how do I send a signal out? I'm going to hear something coming in. I can transmit by talking in the radio, but in order to transmit, I have to press a button to key that up. D, NMEA GPS location and DC power. So the signals, what are the signals used in a computer radio interface for digital mode operation? It's going to be the same signals that you use when you communicate on the radio. It's going to be the audio, the receive audio, the transmit audio, and the push to talk button. So it's going to be C. Which of the following connections is made between a computer and transceiver to use computer software when operating digital modes? Computer line out to transceiver push to talk. So line out means you've got an audio signal going out and it's saying going to the receiver push to talk. Computer line in to transceiver push to talk. Computer line in to transceiver speaker connector. Computer line out to transceiver speaker to connector. So what would it be? You've got a computer line in, it's going to the transceiver. It would be the one that's connecting to the speaker, the line in. The line out, so your transceivers got the speaker, it's going to be emitting the sound. In order for the computer to hear it, it's got to come in the line in. So you got the speaker connector going to the line out. You're sending a signal out from the computer and you're sending a signal out from the transceiver or from the radio. It's not going to make any sense. It's going to, you got it hooked up backwards for the answer to be D. So if your speaker on your radio is emitting a sound, the computer has to hear it. It has to be on the line in. The transceiver push to talk, that's the button on the side of the microphone. You wouldn't want that connected in. Same thing here. Push to talk, that you're not using those. So it has to be answer C. I hope I didn't botch that too much, but you've got the sound coming out of the radio, and to get it into the computer, it has to go in on the line in. So the answer is C. What is an amateur radio station that connects other amateur radio stations to the internet? This one's easy, I hope. A repeater, a digipeater, a beacon,
That'll be a gateway.
a gateway. Answer A. Yes. And when I'm looking over here and you see me looking, I'm not looking directly at the camera. I have a monitor with you all up on. It's over to my left, so when I look over here, I'm looking at you, even though I should be looking at the camera. Okay, let's talk about power supplies. How are we going to run that radio? A solid power source is important for a clean, noise-free transmitted signal and better reception. Usually, a power supply will convert the AC input power to DC current for the radio equipment. Most radio equipment is going to run, with the exception of handhelds. I'm not sure what the voltage is on them, but they're going to run on 12-volt power. If it's in a car, that voltage can jump up to 13.8 volts, but we commonly refer to it as 12 volt. So you're going to take a power supply, plug it into your household current. It's going to convert it from AC into DC, and usually you'll have a knob that you can adjust that voltage, and you want to set it at about anywhere from 12 to 13.8 volts. They recommend 13.8. There are two main ratings: the output voltage and the amount of current it can supply continuously. And you want to know that amperage that power supply can operate at. Radios operate from a 12 volt, and you notice it's in quotes, supply may actually work best at a slightly higher voltage of 13.8. And as I said, that's typical of vehicles, cars, power systems when the engine's running. I live on a farm and I've got a tractor and I've got a radio connected in my tractor. It's not a ham radio, it's a GMRS. And I've got a little voltage meter on my tractor, and it runs up to 14.4 volts, but the radio does just fine. But most cars are going to be typically 13.8 volts. If you don't know the amount of current a radio can draw, divide the output power by the input voltage, then double the resulting current value and round up to the nearest amp. Generally, anything above 8 amps will work for a 50-watt mobile rig. So you need to know what the highest wattage is for your radio. Like my little Yaesu 2980 is 80 watts. So I need to make sure I've got the proper amperage to run that radio. A supply's output voltage changes with the amount of output current. A regulated power supply uses a regulator circuit to minimize the amount of voltage change. So you want a regulated supply. If more than one piece of equipment is hooked up to the supply and turned on at the same time, add all the equipment maximum current needs together. Mobile power wiring. Radio equipment can draw large currents when transmitting. If the wire is too thin, its resistance will create a voltage drop. And you remember we talked about this a couple of modules back. The resulting lower voltage at the radio can cause it to operate improperly, distorting output signal or creating interference. General guidelines for mobile wiring. You should have a fuse on both the positive and negative leads of your radio. When you get say a 2-meter radio, you want to have any radio, but let's just say a 2-meter radio. You want to have it fused on both the positive and negative leads. That's just good practice. You want to connect the radio's negative lead to the negative battery terminal, or where the battery ground lead is connected to the vehicle body. It is recommended by most radio manufacturers is you want to run the wires directly to the battery terminals and connect your radio directly to the battery terminals. And if you can't connect it to the terminals, let's say the battery's hidden somewhere in the vehicle, you want to go to the battery ground lead on the vehicle body. You just can't attach it anywhere. Well, this my car is all metal, so I'll just attach it here. Doesn't work that way. Some of those metal parts may be isolated from the electrical system, and you may not get a good connection, or there may be that metal part may be loosely connected to the vehicle, so you got to be careful. Use grommets or sleeves to protect wiring from chafing or rubbing on exposed metal. You can buy these little plastic sleeves that you can run your wire in, and that just protects it from vibration of the car moving, keeps it from wearing a hole in the insulation on the wire and causing maybe a short circuit. So that's why you want fuses on both terminals. Don't assume that all metal is connected to the battery's negative terminal. I said that earlier. Now, batteries. Batteries are made up of one or more cells. Um, Usually, if you're using a battery with your radio, you're going to have, like I have a lithium iron phosphate battery, and it's 12 volt and it looks like a car battery, but it's made up of many cells inside to get the 12 volts. How long will a fully charged battery power your equipment? Check out table 5.3 in the next slide. And you divide the energy rating in amp hours by the total current needs of the equipment. Remember to use the average current draw of the radio since you won't be transmitting all the time. So if you're not transmitting all the time and you're just sitting there listening, you're not going to be using as much power as if you're trying to send a signal out. Storage batteries are often used as an emergency power source. And when they're talking about storage batteries, they're talking about car batteries. And car batteries can contain strong acid that can be hazardous if spilled or allowed to leak. And they can also release or vent flammable hydrogen gas that can cause an explosion. If you're in an emergency situation and you have to connect up to a car battery, I strongly recommend that that battery be mounted outside with plenty of ventilation because it can explode. Accidentally circuiting a storage battery with a tool or faulty wiring can easily cause a fire or damage the battery. What I do with my battery that I use with my radio, I've actually got it in a battery box. And they make battery boxes with different outlets that you can put your radio battery inside, and it's protected and it keeps you from accidentally short circuiting, and it's got connectors on it so you don't actually accidentally short circuit that battery and cause some kind of fire. And here's the just a sample of batteries. This is not all of them. Of course, we know about AA. They're disposable alkaline. Carbon zinc is a disposable one. Nickel cadmium is rechargeable. Nickel metal hydride is rechargeable. Alkaline batteries are disposable. Nickel cadmium is rechargeable. That one's rechargeable. Coin cells, like the little, look like a quarter, they're disposable. They're lithium. And then lithium ion, as I mentioned, it looks, the newer batteries, they're rechargeable, and but they've got enough cells in there to make up 12 volts, and it will vary on the energy rating. Like the ones I have 100, I have two 100 amp hour batteries, lithium ion, that are rechargeable. Again, a storage battery, lead acid, is like what's in your car, has 2 volts per cell. So if it's a 12 volt battery going in your car, you're going to have 6 cells in it. The downfall of these, they're very heavy. If you short them out, that you can cause off-gassing, or if you discharge them too quickly, they can emit hydrogen gas, which is very explosive. Lithium-ion batteries are very lightweight, and they charge up. They have a lot more capacity to be recharged than lead-acid batteries do, and they have more power to them over time. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? 24 volts at 4 amps. Well, we haven't talked about 24 volts. 13.8 amps at 4 amps. 24 volts at 12 amps. Or 13.8 volts at 12 amps. Which one do you think it's? We can eliminate A and C automatically because our cars don't run a 20-volt system. Most cars don't. And you're running 50 watts. So I'm going to tell you the answer is D because you got 12 amps of power there. And then here, most amateur systems designed for mobile installation will run on mobile power, which is 13.8 volts. The nominal voltage of an automobile battery is plus or minus 15%. So thus the correct answer will contain 13.8 volts. So we automatically know it's going to be this one or this one. As that power supply rating, you will need the 220-volt answers you can automatically get rid of. As for the amperage, E times I equals P. So the two appropriate voltage answers, if you take 13 point volts times zero point 0.4 amps, you're getting 55.2 watts. Well, that could be a correct answer because we're only looking for 50 watts. But when you look at the efficiency losses in the radio, that's not enough power for the radio to output 50 watts. So the correct answer is going to be the 13.8 volts times 12 amps gives you 165.6 watts. So that's more than enough to run that 50 watt radio. This is on the borderline. Depending on, how your radios are connected and everything, this probably is not going to work. So again, where did I get this answer? I got it from Ham Study. So it goes through and explains that, but you want enough wattage to power that radio. What type of circuit controls the amount of voltage from a power supply? Regulator, oscillator, a filter, or a phase inverter. So let me reread this question. What type of circuit regulates the amount of voltage from a power supply? It's going to be a regulator. So think of controls or regulates, and that's your answer. Why are short, heavy gauge wires used for a radio's DC power connection? To minimize voltage drop when transmitting, to provide a good counterpoise for the antenna, to avoid radio frequency interference, or D, all of these choices are correct. It's going to be A, you want to minimize the voltage drop when transmitting. Always use at least as heavy gauge a wire that comes on the radio when you're connecting your radio to a power supply. Most of the time, most radios will come with enough wire that if you're, say it's a mobile radio and you're mounting it in your car, it's going to have enough wire to run from under your dash out to the battery. So the answer is A. Where should the negative power return of a mobile radio be connected to a vehicle? Transceiver means transmit and receive. It's just the radio. At the 12 volt battery chassis ground, so we're connecting the negative power, the black wire. So where's it going to be connected? At the antenna mount? Nope. To any metal part of the vehicle? That would sound kind of logical, but not all metal parts are part of the grounding system in a car. Through the transceiver's mounting bracket. And that's definitely not the case because that mounting bracket may be mounted under your dash to a plastic piece of your dash. So the answer is going to be A, the 12 volt battery chassis ground. What hazard is caused by charging or discharging a battery too quickly? And we're assuming this is like a 12 volt lead acid battery. Overheating or gassing, excess output ripple, halfway rectification, inverse memory effect. And again, we said if you're discharging a car battery too quick, you can have explosions because it's producing a gas. It's giving off a gas. It's overheating. So it's going to be A, outgassing or overheating. How can you determine the length of time that equipment can be powered from a battery? Divide the watt hour rating of the battery by the peak power consumption of the equipment. Now, think about this when we did talk about this. Divide the battery amp hour rating by the average current draw of the equipment, because remember, you're not transmitting all the time. Multiply the watts per hour consumed by the equipment by the battery power rating. Multiply the square of the current rating of the battery by the input resistance of the equipment. Boy, the guys work hard on these answers. But which one do you think it's going to be? When you're looking at this question, you know the radio's not going to be
B,
transmitting all the time. What did you say, Brittany?
B.
B. Divide the battery amp hour rating by the average current draw of the equipment. So think of average current draw, and the answer is going to be B. Which of the following battery chemistries is rechargeable? And that came from that chart, and this is on the question list. Nickel metal hydride, lithium ion, lead acid, and D, all these choices are correct. Well, this one's kind of an easy one because we know lithium ion is lead acid. You know, your car battery is rechargeable. So we may not be sure about this one, but since we know these two are, the answer is going to be D. All these choices are correct. Now, sometimes when they mix these answers up, you'll have A, all the choices are correct up here. So, which of the following battery chemistries is not rechargeable? Nickel cadmium, carbon zinc, lead acid, lithium ion.
Zinc.
Be the carbon zinc one. So B. Sometimes I get these two confused, but remember carbon zinc. And that's the end of module 5, and we're 7 minutes ahead. So let's go out here. Can everybody still see my screen? I'm gonna,
Yes.
I'm
Yes.
gonna pull up, and we're just going to review a little bit. Let me get ARRL up here. Exam review for ham radio. And again, you just, if you haven't done so, go ahead and create an account on both ARRL and Ham Study. And we're going to review for the exam. We're going to go to technique.
Mesh tag. Mesh tag.
Meshtastic.
Mesh.
Yes,
Yeah.
thank you. That's the answer.
Yeah. Yeah.
Meshtastic. That's growing in popularity here in Bowling Green, and we're just on the ground floor. Not a lot of people have nodes yet, but it's kind of neat when you go to a Hamfest and you see these people wearing these little, looks like a little bitty radio, and it's meshtastic, and they can uh, communicate through text messaging. It's connected to your phone. All right, we have talked about T5, so I'm going to just hit one of each one. But so T5A, we're going to talk about voltage terminology and units, and and let's see how good we are. So I don't know the answers here either. I'm going to have to go on memory, and you've seen what my memory is tonight. Electric current is measured in which of the following units? Is it volts, watts, ohms, or amps? Current, think of flow. It's flowing through. Watts is power. Volts is the push behind it. Ohms is the resistance. So it's going to be amps. Electrical power is measured in which of the following units? Well, we just said that. It's watts. What is the name of the flow of electrons in an electronic circuit? Is it voltage, resistance, capacitance, or current? Think of flow, water flowing. Water's in a current, so it's going to be current. What are the units of electrical resistance? And that's going to be ohms. What is the electrical term for force that causes electron flow? And that's your voltage. What is the unit of frequency? Hertz, Henry, Farad, or Tesla?
Hertz.
Hertz. Think of rent a car. And I do all these little memory things to kind of help me. Why are metals generally good conductors of electricity? They're high density. Well, that's true, but that's not the reason. They have many free electrons. They have many free protons. Or all these choices are correct. I'm going to go with B, free electrons. Which is the following is a good insulator? Won't let electricity flow. So we know copper is. We know aluminum is. Mercury is. So the one that's an insulator would be glass. Which of the following describes alternating current? It's changing positive and negative back and forth. So a current that alternates between positive direction and zero. Nope, you can scratch the zero ones. Current that alternates between positive and negative directions. And of course, you can scratch all answers are correct because these two are not. And then which term describes the rate at which electrical energy is used? That's going to be your power. What type of current of flow is opposed by resistance? Direct current, alternating current, radio frequency current. And I know these two are, so automatically it's going to make this one the correct answer. What describes the number of times per second an alternating current makes a complete cycle? And that's how frequent. And so it's going to be frequency. So we did good on that one. So that's the amateur radio, ARRL. And the reason I like that is it allows you to go by subsections of each chapter. Now I'm going to jump over here to ham study real quick. And we're going to look at the technician. I think study mode's what I want to be in. And it's going to require me to log in. All right, so now I'm going to be in study mode. And when you get in study mode, and I'm not used this for my technician license, but it's going to bring up all of the questions for the technician. Well, we want to focus on 5 because we did look at all of the questions in chapter 5 and said how much power is delivered by a voltage of 13.8 volts and 10 amps. So we're looking at the wattage. We want to know how many watts it is. So if we remember, it's P, let's see, what was it? Power is voltage times amps, I believe. So let's see if we're right. 138 watts. Yep. Had to pull that one out from nowhere. Now, if I didn't know the answer and I wanted, let me just go to the next question. What is the unit of inductance? Is it the Henry, the Coulomb, the Ohm, or the Farad? If I don't know the answer, I can say I don't know, and it's going to tell me the Henry. If I want to study a little bit more about that, then you can click on the corner right here, and it will show you and give you an it will explain it to you why the answer is what it is. So you can do that. I'm going to go to the next question, and I don't know it, but I want to practice. It says,
Excuse
what
me.
is the voltage across a 2 ohm resistor if the current is a half amp flows through it? So let's say I don't know that. I think it's 1 volt because a half times 2 is 1, but I'm going to say it's 1.5 volts. and automatically it tells me it's incorrect. I can say, show me the correct answer, or I can guess again and get the answer. And what it's doing, it's tracking over here what my aptitude is for section 5. When
Pat,
I,
excuse me. Thank you. I've got to be on another call right now, but thank you very much. I've really enjoyed it tonight.
okay, thank you.
See you. Bye bye.
Bye bye. And so you can, as you're going through this under each of the sub elements, I wish it broke it down in under the sub chapter of each, like T5, T6, but it doesn't. But since we've already covered T5 and T6, you can practice each one of these till you get that aptitude up. Now, what will happen with ham study is once I get this, go through this, or I sit here and I practice, it will keep coming back to the questions that I miss. And so the questions I get right consistently, they will drop off. But the questions that I miss, it will keep flashcard kind of the questions back to me till I consistently get them right, and then my aptitude will keep going up. So I'm going to move you guys back over to my main monitor here, if I can. There we go. So do we have any questions tonight?
I don't have any questions.
Brittany, do you have any? It's 8:03, so I'm getting ready to.
Not that I can think of right
Oh,
now,
okay.
but thank you.
Well, thank you, and we'll start with Module 6. So we probably got maybe 4 or 5 more classes. I'm not going to rush it, but I think Module 6 will go fast, and so will the others. And so maybe by the 1st of December, you guys will be ready to take your test, and I'm going to help you sign up and take that test. I want to kind of coordinate with you guys so that when you do get ready to take your test, you can do it online. You can do it from your home, and I'm going to be sitting in the room with you, quote unquote, as you take that test. So you all have a good week, and thank you for being here tonight.
You as well. Thank you.
Okay, bye bye.
You have a great night.
You
Good night,
too.
Brittany.